Hello friends, this is Kailash Upadhyay and I'll be taking today's webinar on project quality management. This is a knowledge area in PMP 5. We have 10 knowledge area in PMP 5 and this is one of the most important project knowledge area and also very important topic for any projects. Let's start today's webinar on quality management. The agenda for today's webinar is Introduction to Quality, why quality is so important for organization and why for projects. We have three processes in quality management. First one is plan quality management. The second one is perform quality assurance. And the third one is control quality. Group and control quality belongs to monitoring and controlling process group. So let's understand what is project quality. Project quality management is subset to project management that includes the processes required to ensure that the project will satisfy the need for which it was undertaken. What should be the focus of project manager during all these three processes? During the plan quality management, the project manager needs to plan the quality requirement for the projects. During the execution phase, he needs to evaluate the processes set for the project, whether those processes are working toward the project success or not, whether any processes needs to be modified, changed for the benefit of the project, and during controlling needs to check how is the deviation from the set processes which has been planned in the planning process group. The agenda is defined quality matrix. Matrix is nothing but the measurement unit. How will you measure quality during the planning, during the controlling process group? Okay, as you all aware, measurement are based on two factors: your baseline and against your actual value. So your baseline is set during your planning, and your actual value you will get once you start executing your project. Evaluate processes, measure the actual project deliverables, compare results against defined parameters, and take corrective and preventive action. So this is just about quality. So let's understand first what is project quality. As you all aware, every project has an output in form of some results, some product or some services. The quality refers to the features and characteristics of a product or services. These features and characteristics affects the product ability to satisfy stated or implied need. Let me share an example with you. Suppose your project is about producing a product and the product is suppose an router or a modem through which you can access internet services, wireless services. So the output of a project is a product which is called a wireless modem. Now what is the features and characteristics? Maybe the wireless services should be accessible from the range of 20 meters, and the wireless services should be used from any of the devices which has the wireless service features, like from mobile, from iPad, from laptop, from desktop, or from any other electronic gadget which has a wireless service feature. Okay, so quality is about meeting the stated and implied need of the product, and these need or these features and characteristics are the wireless services, the range, or maybe any functional requirement of that particular modem. Okay, so what is this goal all about? fitness for use. What do you mean by fitness for use? Fitness for use basically means once the product is produced, it should be usable product. When the product has been developed, suppose the wireless modem has been developed, the user should able to use that wireless modem. That means if I want to access wireless internet from my mobile, I should able to use the wireless internet service from my mobile. I should able to pair the my modem with my mobile device, and I should able to access the internet services. So that's called fitness for use. What is fitness for purpose means? Fitness for purpose means, suppose I have during the product design phase, collect requirement phase, I have set a feature and character saying that it should be accessible from 20 meters. That is my purpose, that I want to access a wireless service at a range of 20 meters. Whether I am able to use that 20 meter range wireless or not, that is called purpose. So my product is, it should be fit for use, should also fit all my purpose. Not only that, if I'm able to use the wireless service from a 2 meter, 3 meter, but my purpose was to use it from 20 meters, whether that purpose has been solved. So that is called fitness for purpose. Customer satisfaction. No, when will customer be satisfied? When it will be fit for use, when it will be fit for the purpose. That means when it delivered entire features and characteristics as defined during collect requirement phase. So collect requirement phase, during scope management knowledge area, you collect the requirement, and the requirement are not only project management requirement but quality requirement, functional requirement. So it has to meet all those requirements. Conformance to requirements, this is what I'm trying to tell you. Conformance to requirement, you collected the requirement, and now at the end the product has to confirm all those requirements, and then only the customer will be satisfied. Okay. Now let's understand what is the difference between quality and grade. Okay. Let me give you an example. Let me take the same example again, the wireless modem. Okay. Quality and grade are basically have same functional use. Okay. Quality is a totality of characteristics of an entity that bear its ability to satisfy the stated or implied need. A grade is a category or a rank used to distinguish items that have same functional use. Okay. Now let me share an example. Suppose my product has been delivered, wireless modem has been delivered, but I am not able to access the wireless service from 20 meters. I am only able to access the wireless service within a range of 10 meters. If my range of my phone, my iPad or any device is beyond 10 meters, that means I'm not able to access wireless services. So that means my quality has been delivered. My modem has been produced, I'm able to use the wireless service, but it is not fit for that purpose. So grade basically means my quality is okay. I'm able to use wireless service, everything from iPad, modem, and any desktop, laptop, or any other gadgets. But the grade is very low. It's supposed to have 20 meter range, and the range is only 10 meter. Okay. So quality, if you don't deliver quality, low quality is always a problem. Low grade may not be. What would have happened if that modem, through that modem which has been produced as a result of a project, you are not able to access wireless service? That means it is a low quality. The modem is there, but you are not able to access wireless services from that modem. So that means low quality is always a problem. Low grade may not be. So instead of 20 meters, you are able to access the wireless services from 10 meters, or maybe say suppose 15 meters. So low grade, sometimes customer may, he will definitely not be satisfied. So one of the requirements which I stated before, customer satisfaction. Probably you must have not met customer satisfaction, but if it is the product is fitness for use. So customer will not happy, but low grade may not be sometime a problem. And it depends on customer to customer. Let me state that one more that again. So low quality is 100% of a problem, and low grade may or may not be a problem. So I hope you must have understood quality versus grade. So quality versus grade means same functional use. Even the grade will also have the same functional use which has been defined, but it is not meeting the exact purpose of that particular quality. This is what PMI says about quality. Quality stands for conformance to requirement and fitness for use. PMI affords the concept of prevention over inspection. That means it is a project manager responsibility to prevent problem rather than the problem has found and now project manager is trying to overcome the problem. It may be possible that the project manager may have have solved the problem within time or before time, but it is the duty of project manager to prevent problem because prevention has less costly than inspection. Let's understand another term called gold plating. That is giving extra adds no value to the project. That means if customer wants a modem to be accessed only from 20 meter of range, so don't try to work something extra that you deliver a modem which is you're able to access from 100 meters, or probably you must have overspent additional time and additional cost to make customer satisfaction. So no, that's not called customer satisfaction. That's called gold plating. So giving anything extra is called gold plating. So it is a project manager responsibility that deliver whatever has been collected during collect requirement process. Okay, it should only conform to requirement, not anything extra. Continuous improvement. Continuous improvement is also is referred by a term called Kaizen. Kaizen is a Japanese term. Kai means Kai means is continuous, and Zen means improvement. That means every project needs to continuously evolve continuously. So when suppose the project is multi-phase project, okay. So when the first phase is started, so you have much more detail. Probably you don't know what is there into the phase 4 or phase 3. So as you come closer to the phase 2, phase 3, you try to develop more and more detailed plan. So same goes with quality. So try to improve quality over a period of project. So you have to ensure at the end of a project it meets all the stated and implied need of that particular project. So it's always difficult to have a detailed plan from the very beginning. Okay. So while the project is in process, in planning, execution phase, try to do brainstorming with your stakeholder. Try to do other techniques to improve quality, to improve project's performance and success. So that's called continuous improvement. Just in time. Just in time, many companies find that holding raw material in inventory is too expensive. That means it is very difficult to have the raw material to all the the bench strength of the people, like software company. Earlier they used to keep lots of bench strength to support the customer and all those things. But bench strength is also a cost to a company. So whenever you require additional resources, you ensure that at that point of time only you hire or you get that material collected or gathered for the project. So just in time basically means whenever it is required to save the cost. So if you don't have, your company don't have a cost, if you want to save a cost, so use just in time methodology. So this is some of the concept before we take quality we should look into. Now today we will cover the 7 basic quality tools. What are the 7 quality tools? How to plan quality using this 7 quality tools. The first one is called cause and effect diagram. The second is the flow chart, check sheet, Pareto diagram, histogram, control chart, and scatter diagram. Let's understand these 7 tools in details. The first tool of quality is cause and effect diagram. This cause and effect diagram is also called fishbone diagram and Ishikawa diagram. A person who invented this tool is named after him, called Ishikawa. So what is this cause and effect diagram? The purpose is to identify root cause of a problem. So it is a tool to identify root cause of a problem. So let's understand how this tool is used for quality purpose. What you trying to do in quality purpose is trying to find out the factors which can impact your quality, which can impact your project outcome. So your problem and your desired outcome or any solution which you want to get should be into the head of a fish. This tool is also called fishbone diagram because it looks like a fishbone and all. Okay. So the problem or the defect should be, the effect should be into the head of the fish, and then you try to find out what can cause a problem. And these factors you try to collect while planning processes, planning quality. So any quality related problem can be, people is the one could create a quality problem, management, material, and process. People then further, whether the people don't have skills to complete that particular product, whether people don't have training, whether it's insufficient people or people are overtime. So how can people impact the quality of a product? This is what you need to find out during quality planning, that how can people improve or how can people affect your quality of your project. Okay, so try to identify people related problem. So like skills of a people, they are not skillful to do the work on which they have been assigned. Whether they are working overtime, they're working on 2-3 projects simultaneously. So whether that can be a problem of a quality. So identify the problem. Same way, identify the processes, which are the best quality processes. And how, if the process is not correct, and how this incorrect process can lead to a quality problem. Same way, management. Quality is all about management. How serious management is about that particular project or that delivering that particular output, which is a product. So identify these factors or these inputs which can lead to quality problem, and probably use, if you find any problem while monitoring and controlling your project, while governance of your project, find out which of the collected problem, like process, people have impacted or has caused that particular problem into your process. Okay, so cause and effect diagram is all about identifying the factors which can create a problem in your project or which can improve the quality of your project, and use this tool while monitoring and controlling to find out the which has worked in favor of project and which has not worked in favor of a project. The second tool of quality planning and control is system or process flow chart. I hope many people among us have seen the process flow chart or a system process flow chart. Basically, when you start any project, let it be any project, if it is properly documented, if it is properly designed, in case of software projects, again, the high level design, HLD, the low level design, if you have all those design documented correctly, it will be very useful for the team to follow that design and identify what is the sequence and what has to be done. So the process flow chart is, again, when you plan quality, you need to understand how you will follow, how the process, what is the start of a process and what is the end of process, and what kind of decision making is happening which can create problem, and where you need to do a looping in your project. So process flow chart will tell you that which are the processes and how the processes break down to achieve the product output or achieve the goal of a project. Okay. So we have a process, and I hope you have seen this kind of process flow diagram tools like this. Are the transportation things. This is if you want to add some delay, you can add this kind of symbols, or a storage database. So these are the various flow chart related symbols which should be used while these are the global standards. These are not for project management standards. These are global standards or global symbols which are used in process flow chart. So if you want to start, you want to say some database storage related symbol you want to show in a process, that some data is getting stored into database. So use this kind of symbol. And if you want to have any decision, a decision can have yes or no decision kind of thing. So use a decision symbol. So these are the global symbols which should be used while defining the process. And this process will, if you have properly defined process, your success of project is much more than without documented process and all. Just assume when you have a new team member join, and if you don't have a process defined in your project, what will happen? Somebody needs to manually give him the download, and that time is wasted. But if you have this properly defined process and justification of each and every input, output, and process, that means the person has will take little less time to understand your project process flow. This is all about process flow chart. Now, our third quality tool is check sheet. Guys, this is not checklist. This is a check sheet. Check sheet is different than checklist, and this is also called tally sheet. So the PMP exam may refer it check sheet or a tally sheet. So don't get confused, and also don't get confused with checklist. So the checklist is basically about monitoring whether each and everything had been delivered or not. It is a list of just like process, whether this one process has been followed or not, second process has been followed or not, about the product and all. So it is about checking whether what has been followed, what has been not been followed, which has been collected during planning process. In case of check sheet is basically recording of or tracking of data during the execution phase. That you have planned something, whether how many defects, how many issues about that particular problem you have observed. Let's see shortages of raw material. You want a vendor to deliver a wireless modem to you, and the delivery has been delayed by suppose a 2 months. What are the problem of that delay in delivery? So that category we will define as shortages of raw material. That could be because of shortages of raw material, the product is not able to deliver in on time. The second could be the transportation issue. There could be a strike of a transportation strike and all. The third one is shortages of a labor availability, inexperienced worker, aggressive timeline. So these are the problems. Okay. Now, what are the frequency? How many times you have faced this kind of problem? So recording or tracking a shortage of raw material. There were 3 times you face that you have not received the material on time. Transportation issue of raw material. That means you are not able to transport the raw material on time. You get or maybe deliver to the customer. So check sheet is or a tally sheet is about keeping track of how many problems you have faced while execution of your project. And checklist is just about whether everything has been correctly delivered or correctly completed or not. So I hope you must have understood the difference between check sheet or tally sheet between checklist. Now, our fourth quality planning tool is histogram. Histogram is also called a bar chart, special form of a bar chart. You have collected various problems in your check sheet while planning. Various problem has been done. Now plotting those problems into a bar format or into a pictorial format and identifying which is the greatest problem of your project. This is what is the use or role of histogram. So that means you have identified various problems and depicting those problems for better understanding and greater impact, and you can identify which problem is worth dealing. So in case inexperienced worker, which is the highest problem area in your project. So you need to, by looking into this highest bar of your histogram, you can identify the inexperience of your worker is the problem in a project and which needs to be handled first. So histogram is nothing but a bar chart which graphically tells you that which are the problems in problem area or which are the multiple solution area. You can use this histogram for problems also which are the multiple solutions in your project and which solution is the most which needs to be most prioritized. So same way you can create a histogram for positive area as well as negative area in your project. So inexperienced worker is the highest problem in your project and which needs to be handled first. So that's called histogram. Now fifth quality planning tool is called Pareto diagram. Pareto diagram is also called 80-20 rules. 80-20 rules basically is nothing but, many of you must be knowing, 20% of the problem, 20% of the causes can create 80% of problems in your projects. Okay, so this means 80% of the problem are due to 20% of the root causes. So try to find, this Pareto diagram tells you that which are the 20% of the problem which if you try to handle, try to focus your project management time into 20% of the causes, then your 80% of the project problems are solved. So Pareto diagram is about prioritizing the potential causes of the problem. What are the 20% of the causes which are leading to the problems in your project? It helps focus attention on most critical issues. Which are the 20% of the critical issues? If you handle, that means 80% of your project problems are solved. Okay. So that's called, this tool is developed by Joseph Juran, adapted by Wilfredo Pareto, and that's why it is also called Pareto diagram. Pareto diagram is also called ordered histogram. What do you mean by ordered histogram? Ordered histogram basically means you have seen a histogram in a previous chart. That means, so highest problems are listed first, and then the second highest problem, and then so on. So it is in an order of frequency and all. So inexperience of work is the most problematic area in any project. So if you work on inexperienced worker and aggressive timeline, these two areas, that means your 80% of the project problems have been handled. So this is the use of Pareto diagram in your project, understanding which are the 20% of the causes which are leading to 80% of problems in your project. That's called Pareto diagram. Now, so what I will do before covering to the last two quality tool. Any questions, guys, so far about understanding of quality definition and what are the 7 basic quality tools or the 4 basic quality tools we have covered? Please raise your hand so I can take your questions, or you can put your question into your question and answer panel as well. Any questions? Just a 2-minute question and answer break. Please raise hand or put your question answer into the chat panel so I can take your questions on histogram, Pareto diagram, process or a system flow chart, and cause and effect diagram, or any definition about quality and understanding of quality. Okay, so I hope people are so far with me. There are no questions from anyone. So let's move on. Our 6th quality tool is called scatter diagram. Scatter diagram is basically the diagram tracks 2 variables to see if they are related. Let me give you an example of scatter diagram. This is y-axis and this is x-axis. So scatter diagram consider 2 variables, a dependent variable and an independent variable. Let's say this is independent variable and the y-axis is a dependent variable. And independent variable is suppose experience of your project team. Experience. Okay. Experience. And this is accuracy. Let's say accuracy. So if your people experience is increasing, so as whether your accuracy of product deliverable are increasing, so that means accuracy, suppose if you have one accuracy as here, this is experience of suppose 5 year, 10 year, 15 year, 20 year, or maybe 2 year, 1 year, so on. So if you have 5 year person, whether the experience is having an impact on accuracy of a deliverable. If you adding more experienced people, whether your accuracy of deliverables are getting improved or not. So your independent variable is called experience and your dependent variable is called accuracy. As you increase more experienced people, add more experienced people in your project, your accuracy or your on-time performance of your deliverable will be higher. Okay. So something is called positive correlation, and sometimes it happens at negative side also. Okay. So scatter diagram is basically about diagram is tracking 2 variables to see if they are related. And I have also covered example here. The length of time an employee has performed a task and the accuracy of achieve. The same thing. If the person performs the task the longer time, whether the accuracy is impacting. So any two variables you can take in your project and try to find out how they are related. Whether after changing one variable, improving or reducing. If you're removing instead of 4 resources you want to perform one task, if you remove one resource, how it is have an impact on your quality. So there could be negative correlation also. There 4 people are required to produce this particular work package or any task. So if you instead of 4, if you're saying 3 people, what is the impact on your accuracy of your product or a deliverable? So you can plot that kind of relationship between dependent variable and independent variable and try to find out what is the correlation and try to produce to your management, to your sponsor and to customer and tell him that if you remove a resource or if you add experienced resource in your project, your quality will be improved, or if you remove the resource, the quality of a product will be reduced. I have a question from someone. I don't know a name, but let me unmute. Hello. Hi, this is I have raised hand by Guy. I don't know who is this. Can you please put your question forward? Hello. Okay. So I hope scatter diagram is clear. Scatter diagram is about identifying the area which can improve your quality problem, identifying the factor, whether by changing the experience of people, by reducing the resource, or cutting the quality, the raw material which is a cheaper quality, how it is impacting your project outcome. So take 2 variables at a time and try to find correlation among the 2 variables and try to produce a result. And while this is again during the planning process, and try to show the impact of improving the quality of a material or a cheaper material, and so how can you improve. So this kind of things you need to do during maybe to manage your schedule or to manage your cost. Sometimes your cost is going over budget, so you may have decided that you will cut some of the quality. So cutting quality means a cheaper material, low quality material, maybe reducing the manpower so that you can achieve your cost goal or cost objective. But also try to find out the impact that if you cut the quality, how it will impact your customer satisfaction. So this is by tracking that variable, 2 variable, that is called scatter diagram. Now let's understand the 7th quality tool. It's called control chart. Control chart is basically, let me again take you the example first, the wireless modem. So you wanted the wireless modems to be used. The purpose was to access the wireless services from 20 meters. So that 20 meters is your mean. So in a control chart, you have a mean value, which is suppose 20 meters. Now there is something called control limit. Okay. Control limit is plotted by a dotted line. There is a lower control limit and there is a upper control limit. So even if the your quality control limit, suppose 20 was the mean, was the initial requirement. Suppose between 22 or 19. Even if it is between 19 and 22, your quality you don't have to bother about. So this is something called your threshold value, where you don't have to perform any corrective or preventive actions. Okay, and this threshold value is also called control in a control chart, also called control limit. Your control limit is between 19 to 22 or maybe 18 to 22. Okay, so even if if you measure the first modem and if you see wireless, if you see the result of that wireless modem which has been produced, if you're able to access that particular modem, wireless service from that modem from 18 to 22 meters, that means that product has been accepted quality of a product. Okay, so 20 is what you have collected during the collect requirement phase, which is the quality requirement and which is the mean value, and 18 to 22 is the control limit. That means after the product has been produced and you are checking the quality of that particular product, and if you're able to access the wireless services from 18 to 22 meters, that means quality is acceptable and that product is good, fit for use and fit for the purpose. So that's called mean value. This is called control value. Okay. Now this control limit depends upon quality of an organization. This is control limit of a project of an organization. Okay. And the deviation from a mean, which is also called deviation, is something called sigma. So this could be 6 sigma, 3 sigma, 2 sigma, depend upon the projects or depend upon the organization. So the upper side of the mean and the lower side of the mean, they also are called sigma, 6 sigma, 3 sigma. So it depends. Most of the project 3 sigma or 2 sigma, 3 sigma is nothing but 99.97% of quality results. So that means your modem is, if you are able to access the modem from 19.97 meters of range. So that means that is about 3 sigma quality has been achieved. So you can define that your sigma range, deviation from the mean. So that's called sigma, or called deviation from the mean. Now there's something also called a specification limit. Specification limit is above or below the above control limit and below control limit. So this is called upper specification limit, which is above your control limit, and this is called lower specification limit. Specification limit is about what customer will accept. So the control limit is about the project control, which is the performing organization control limit which performing organization wants to achieve. But customer will accept your product if you are able to access the wireless services from suppose 16 meter to suppose 24 meter. So that is acceptable customer acceptable range. So even if you so that means a low grade product is a low grade product, but it is accepted, it is fit for the use. Okay. So that means if you are able to access wireless services from that particular product which has been produced from 16 meter, a customer will accept your product and he will probably he will pay you the full value of your product or services. So specification limit are always above or above the upper control limit and below the lower control limit. Okay, so this is also called customer acceptance limit. 16 to 20. These are just an example numerical value which I have plotted into this control chart. This entire is called control chart. Now suppose this is you have defined your mean value, you have defined your control limit, and you have defined your specification limit. Now let's just assume that your product has been produced and you are observing or you are checking the quality. Now the first product which you want to check the quality is suppose it at this range. It is below the upper control limit and above the mean. So that means this is acceptable quality. If the second observation, the second product which you pick up is again below the mean value, this also be accepted. But consider if the modem is at this range, which is above the control limit, that means this is not acceptable quality. Customer may accept that particular product, but it is failed the quality requirement of that particular project. Okay, so it is above the control limit, and this is also called assignable cause or a special cause where the project team needs to take preventive action, corrective action, or any defect repair. If the product has been produced, that means you need to do a defect repairing of that particular product because the result is above the control limit. Okay. Now let's go back. The first product which you are checking is above the control limit. The second you are checking is again above the control limit. The third product is again above the control limit. Fourth, fifth, sixth, and seventh. If you are checking non-random product, or if you are checking the random product, and all 7 random products which you are picking up and all are above control limit, this is also called rule of 7. That means the last 7 observation, continuous observation. This is continuous observation. It's not that this the first is here, second is here, then third is here, fourth is here. No, all 7 observations which you have considered for quality check, all are above mean or all are below mean. That means that is also called a quality problem, and you need to take you need to take special cause, defect repair, you need to repair, or you take preventive and corrective action. So 7 continuous observations which is above the mean value and below the mean value. Even if it is within the control limit, above or lower control limit, there is a problem in your process. That means you need to change your process so that the quality is achieved and all. So that's called control chart, or called control. How during planning process you need to identify your specification limit. You need to identify your control limit. Who will give your control limit? Your PMO, or maybe your program manager. If your project is part of a program, your program manager will give you the control limit for your particular project, because program manager manage interdependencies between multiple projects in that particular program. So this control limit, this range, the deviation from the mean will all be given by probably your program manager, your PMO, or your sponsor, or your customer. So this is about 7th quality control tool. Now I am done with my today's webinar about 7 quality control tool. I'm ready to take questions. If you have any questions, or I have put some questions about quality. So any questions, guys, on quality, 7 quality tool, or what is your understanding about quality? Any questions? Okay, I have some questions about quality.
So folks, if you still have any questions.
Okay, here is my question about quality. I would just mention your ABCD in your chat panel. A project manager is analyzing the defect arising in the end product and also trying to understand the top 5 causes which are contributing to these defects. Which combination of tool can best be used for this purpose? Okay, I got D, C, A. Okay, I got correct answer from Gauri. Gauri said D. Rich said D. So D is the correct answer. Here, fishbone diagram. Let's read the question one more time. A project manager is analyzing the defect arising in the end product and also trying to understand the top 5 causes. If you're trying to find out the defect in your problem, so that means you are doing root cause analysis. So fishbone diagram is also called root cause diagram. Okay, and then top 5 problem, that means Pareto analysis, that 20% of the problem, that maybe that these top 5 problems are comprising of 20% of your causes which are leading to 80% of the problem. So this correct answer for this is fishbone diagram and Pareto analysis. Let's go to the question number 2. Which quality process is being followed here in this question? So I'm getting C, B, D, Gauri said D, and I'll wait for some more. Sheikh Ismail says C. D. Okay, so friends, I hope I think you have not understood the questions correctly, and I have only got correct answer from Nivasini. Nivasini said A. A is the correct answer. Here it is saying which quality management process. First of all, design of experiment, D, is totally incorrect because it is not a process. We have only three processes: plan quality management, quality assurance, and control quality. So D is not a process, so D is absolutely incorrect. And here it is asking in a question, the project management team is using a fishbone diagram to identify the factors which would have a greatest impact on the product fitness for you. So you are identifying. Identification is done during planning phase. Okay, so during assurance and during controlling, during assurance you will execute your plan, and during controlling you will do checking of quality, whether the quality is as per the acceptable limit or not. Okay, here it is saying it is identifying the factors which can have a greatest impact of fitness for you. So which are the factors which can impact your fitness for use requirement of your particular product? Okay, so plan quality management is the correct answer for this question. During planning phase, you will identify factors which can create problems in your quality, or which are the solutions for your quality problems. Okay, so planning is about identification of problems or identification of solutions of quality related quality solutions or quality problems. Okay, Mohammed said B. Sheikh Ismail said B. Okay, so this is, I think, so correct answer is given by everybody. So how far the measurement is from the mean? That's called standard deviation, which is also sigma. How far your this measurement from the mean, which is acceptable by that particular project manager, or from that by that particular PMO or the program manager and all. So how far is the deviation from the mean is called standard deviation. So it has been rightly said by everybody. That's really good. Let's go to the fourth one. Okay. So Barbara said D. Yolanda said D. Okay, Naswini said D. D is absolutely correct answer. See, focus on most critical issue. Somebody said A. A is not correct. Focus on most critical issue to improve quality. It's about Pareto 80-20. What are the most critical issues? Identifying that's part of Pareto tool. Focus on stimulating thinking and explore a desired future outcome is about cause and effect. What are the stimulate? How you are thinking? What are the identifying causes? This is about these B and C is about cause and effect diagram. What are the stimulating thinking? What are the factors? And what are the desired future outcome? What is the output? Those are called fishbone diagram. Determining if a process is functioning within a set limit is the purpose of control chart. I hope you will agree with that. And let's go to this one. Okay, I have already described this. Pareto diagram is focused on most critical issues to improve quality. That means which are the 20% of the causes or identifying solutions which can have maximum impact on your project quality. So focus on most critical issues or most critical solution to improve quality is the correct answer of Pareto diagram. So Pareto is also called ordered histogram. You just understand from the exam perspective also. So you have a histogram. Histogram is just about depicting the various observation into in a bar chart format. But Pareto diagram is not only depicting into bar chart format, but with the most critical problem or most best solution are depicted first, and then so on. So that means that the most important problem, the focus on most critical issues or most critical solution, That is the purpose of Pareto diagram. So this is about definition. What do you understand by quality? Okay, I think so. You have really understood this quality topic really correctly. So quality is C is the correct answer from everybody. The degree to which project meets requirement, not about management objectives. Okay, quality is about meeting the requirements of a product. My project will produce me a wireless modem. That is the result, product, services. So quality means ensuring that all features, all functions, or all requirement which has been collected for that particular product has been delivered to the most satisfactory level. So degree to which the project meets requirement, that is the purpose of quality. It is not about ensuring management or making customer happy. So don't do gold plating to your management, don't do gold plating to your customer. Okay, whatever has been collected or what has been requirement gathering has been done, deliver that to the 100% level. Nothing less, nothing more. So that is the all about quality in a project. Okay, so you all are correct. This is called gold plating. This is what I'm trying to tell you. A project manager has to be very smart enough. His job is not to make customer happy by giving anything extra. Definitely, customer satisfaction is one of the goal of quality. But making customer satisfied by overtiming or by overspending or making your team overworked. So that is not the purpose of quality. Quality means ensuring customer satisfaction, but by giving that satisfaction for what has been collected, what requirement, delivering the requirement, not by giving extra. Okay, so don't try to if your product requirement is 20% wireless range, only try to work for 20%. Don't try to make customer happy by 100% range by putting 1 month additional time or by putting additional resources, additional cost. Okay, that's called gold plating. So this is about quality. So I have covered my quality session today. I am still open for your quality questions.